Hello.
Hello, sir.
Okay, good morning. Guys, we're gonna have some class now. Okay, after that, maybe after 25 minutes, I will stop. And after that, I will send you first quiz questions, maybe through Telegram or maybe through your email. Okay. So after you receive this, you have to solve the questions, and after that, you have to scan it well and name it as math actually 241 and your name and surname and send it back to me before the what is it, before the due actual time. Okay, so here we were talking about partition of matrices yesterday, and today we will continue that concept. And of course here we are going to consider some special ones. So we begin by considering some special cases of these partition matrices. So actually you will see that each gives rise to a different way of viewing the product of two matrices. Now suppose we are given matrix A whose size is m by n and matrix B whose size is, what is it, n by r. Okay. And here, if we partition B in terms of its columns, so this one is matrix B, now we are partitioning this. How? Actually, we are just grouping it as entries or elements, right? And denoting by another matrix. So here we have this one, B1 is the first column and the second column and third, rth column, because this one is, B is n by r matrix. So see here, actually, number of columns of matrix A is the same as the number of rows of B. That means that product multiplication for these two matrices, I mean A times B, is defined. Okay. So now if we multiply A by B, what happens here? Here we'll have A times B, right? Matrix A, here we have A, and B we have already partitioned like this here, B1, B2, BR. And here just keep in mind that each vector, or let's say each matrix here inside, for example, let's say B1. What is the dimension of B1? It has how many columns? It has n columns, right? Here we have something like this. Its entries are something like this: x11, x21, dot, dot, dot. And here we have, what is it? N1, that is n1. In similar way, BT is also this kind of matrix. It's like a vector, right? A column vector or column matrix. Okay. So now, as you see here, the dimension or the size of this matrix is, what is it? N by 1. Now here, the size of A is m by n. So as you see here, m by n is multiplied by n by 1, right? So this n, they are the same, and the product matrix will have the size of m by 1. Okay, this one is a m by 1. So that means that I can actually multiply this a by b1, a by b2. So in this way, now if we multiply this, we will have this kind of matrix. You see here, it's in a more compact form. Matrix A is multiplied by column matrix. Matrix A is multiplied by another column matrix, blah, blah, blah. And as you see here, what is the size of each one? The size of each one is, for example, this one, the size is this, that is m by 1, right? M by 1, M by 1, M by 1. How many columns? We have R columns. Okay, so in this example, using the matrix column representation, compute AB for the following matrices. Okay, we know how to multiply this, but here, just to practice this, we are going to use this method. To do this one, first step, I will write this matrix B as, what is it? Matrix column. First, let me just write as the columns of other matrices, or just columns. Let's say this one is B1, and here we have B2, and where B1 is, what is it? It is 3, 1, 5. And here we have B2. It's the second column of matrix B, that is 0, -4, and 3. Let me use different color. All right. So now that means that here we are multiplying like this. A times B equals A times, here we have B1 and B2. And that is equal to A B1 and A B2. So to do this thing, I should just multiply this matrix A by B1, matrix A by B2, and just write this as columns, and you'll get a product. To do this one, so here we have A, B1. What is A? Matrix A is 1, 3, 2, 5, and 1, -2. And how about this column matrix B1? It is this 3, 1, 5. So here we have 3, 1, 5. And we know how to multiply this. This one is 2 by 3, 3 by 1. So we will have the answer 2 by 1. So we will have something like this, right? So if you multiply the first row by the first column, 1 times 3, 3 plus 2 times 1, 2, it is 5, plus 1 times 5, it is 5, so it is equal to 10. So this thing is 10. And multiply the second row by this column matrix, that's 3 times 3, 9, plus 5 times 1, 14, 14 plus -10, that's equal to 4. So now we got the first column of this product, that is 10 and 4. So how about the second one? To do this, we should multiply A by B2. So A is 1, 3, 2, 5, 1, -2. That is, here we have 3. Actually, B2 is 0, 0, -4, 3. That is 0, -4, and 3. So that is equal to 0 times 1, 0, 2 times -4, -8, plus 3, that is -5. And let's multiply the second row by this column. 3 times 0, 0, 5 times -4, it is -20, plus -6, -26. Now we get the second column of this product, that is -5 and -26. Okay, that is another way of multiplying two matrices. All right. So next one is we have another special partitioning, that is, what is it? Row matrix representation. Actually, we need to have the first topic. Row matrix representation of a product. So here from its name, here we have row matrix. That means that we are multiplying rows by a matrix. In the previous one, it was column matrix. We were multiplying column, right? Actually, the columns by the matrix. So here, again, suppose that we are given a matrix A, whose size is M by N. And here we are given another matrix B, whose size is N by R. And we know that if you multiply A by B, we will get C, and the size of C will be, what is it, M by R. Okay, so now let's just partition this matrix A, and the right, it is rows as A1 and A2 and AM. So each one is this capital A1. It represents the first row of matrix A, A2, the second row, AM, the third row. Right here we have just right, for example, let's say A1. What is it? It is the first row of matrix A. So here we have, what is it? A11, A21, A31, dot, dot. How many columns? It has N columns. So that is A, first row, second row. No, not like that. A11, they are all first row. A12, A13, dot, dot, A1, N. Right? Or the second one is, let's say this second one, that is A21, A22, A23, dot, dot, A2N. Okay? So in this way, actually, we partition matrix A. Now that one is matrix B, it's just B. As you see here, the dimension of each row vector here, what is it? It is 1 by N. So the size of B is n by R. So here we have 1 by n. Matrix is multiplied by n by R matrix. And the product matrix will have the size of 1 by R. Each one is 1 by R. That means that here also this multiplication is defined. So here, if you just write here as A times B, and what is A? These are A1, A2, AN partition in this way, times here we have matrix B, right? Just multiply this. You should multiply each row matrix by B. Here we have A1 times B, A2 times B, blah, 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 AN times B. And this is, once again, another result of, what is it? Another way of multiplying two matrix. And once again, this result is a direct consequence of the definition of matrix multiplication. So that's called a row matrix representation, because here we are multiplying this row, right? Row matrix. The previous one is matrix column, because you are multiplying matrix by a column, but here we are multiplying row by matrix. So that's called a row matrix representation of a product. Let's see one example. Using the row matrix representation, compute AB for the following matrices. So here we have A, right? So we can just write this A as capital A1, capital A2, because it has two rows, where capital A1 is this row vector, that's 1, 2, 1, and capital A sub 2, that is 3, 5, negative 2, right? So if you multiply here, let's say A times B. What is it? Here we have cap A, that's A1, A2, and multiply by matrix B. So that's equal to A1B, and here we have A2B, right? To write these things, we should actually multiply A1 by B, A2 by B. Let's just do them here. So A1 times B. A1 is a row vector whose components are, elements are 1, 2, 1. And B is our matrix here. That is 3, 0, 1, negative 4, 1, negative 4. And here we have 5, 3. So this one is 1 by 3. This one is 3 by 2. So here we will have a matrix of size 1 by 2. 1 by 2. So multiply the first row by the first column. 1 times 3 is 3. 2 times 1 it is 2. 1 times 5 it is 5. So here we have 10. Now the second element, 1 times 0, 0. 2 times negative 4, negative 8 plus 3, that is negative 5. So now I got the first row, right? That is 10, negative 5. And now we should write the second row. That is A2 times B. A2 is 3, 5, negative 2. And here we have matrix B, 3, 0, 1, negative 4, and 5, 3. Equals, and we'll have 1 by 2 matrix here. 3 times 3, 9. 5 times 5 times 1 is 5. Plus 9 is 14. Plus negative 10. That's equal to 4. And 3 times 0, 0. 4 times negative 4, negative 20. Plus negative 6, negative 26. So here we have 4, negative 26. Another way of multiplying two matrices. All right, and again, the definition of the matrix product AB uses the natural partition of A into rows and B into columns. This form might well be called the row column representation of the product. That is another, special, way of partitioning matrices. So that is actually the definition of the product of two matrices. Column, row. So the first one was, matrix, column. Second one is row, matrix. But now here we'll see column, row representation. That means that we are multiplying the columns of this columns of the second matrix actually by the rows of the first matrix. Okay. All right. Here column row. Here, again, since we are talking about the same matrix, we are just here, what we are doing here is we are observing or just studying different ways of multiplying two matrices. Again, here we have this matrix A, whose size is m by n, and B, n by r. And let's say we're just partitioning matrix A as its columns, like A1, A2, AN. These are the columns of matrix A. And B by its rows, B1, B2, Bn. So actually rows are partitioned as this, right? So now as see here, if you just multiply A by B, what do we have here? Here we have A1, A2, AN, and B1, B2, Bn. First, make sure that actually this multiplication is, what is it? Defined. As see here, if you just write the size, what is the size of A1? A1 is a column vector, right? It has m rows here, so that is m by 1. And how about B1? B1 is a row vector, so its size is 1 by r. So it is 1 by r. That means that here we can multiply these two things, these two matrices. And the size of the result will be m by r. See here we have m by r, right? And if you just add all of these two matrices together, we will get the product of AB. That is also another way of multiplying two matrices. So these are the columns, these are the rows, and that is A1 times B1 plus A2 times B2 and plus blah, 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 AN times BN. Okay, and actually this one, they have a special name, this AIBI. Here we have each term or each matrix here, right? These things actually, they are called outer product of these two matrices. And this A1, B1 plus A2, B2 all together, actually, they give us the product of these two matrices. That is called outer product expansion of AB. Actually, these terms we will use in the future, maybe in chapter 6 or 7, okay, later. But now I'm just showing this to give you some idea about how in different ways we can multiply two matrices. Compute the outer product expansion of AB for the following matrices, right? To do this one first, we need to write this A as its columns. So here we have, let's say, A1, A2, A3, where here we have A1 equals 2, 0, and A2 equals, it is 3, 1, and A3 equals 1, 7. And how about B? We can just write B here, B as its rows. So this one is B1, the first row, B2, the second row, B3, the third row. Okay. So here we have B, and these are the rows of B, where B1 is the first row of this matrix, that is 9, 0, and B2, that's the second row, it is 1, 4, and B3, that is 2, 3, right? Now, if you multiply these two matrices together, what do we get here? So that is A times B, right? It says compute the outer product expansion. So to do this one, we need to write or partition this A. What is this? Columns. So columns are, here we have A1, A2, A3, and times, how about B? Rows, B1, B2, and B3. So which is equal to A1 times B1 plus A2 times B2 plus A3 times B3. So we need to compute each matrix here, each product here, and evaluate this, right? And what is the advantage of multiplying in this way? And here it's like a dot product, right? Here this one is column matrix, this one is, what is it? Not dot product is a bit different, but we are just multiplying a single number. I mean, this the first component by the first component, second component by the second component. And okay, here A1, B1. Let's just write this. What is A1? A1 is 2, 0. And how about B1? B1 is 9, 0. So as you see here, this one is 2 by 1, this one is 1 by 2. So here we will have 2 by 2 matrix. So 2 times 9, it is 18. 2 times 0, it is 0. 0 times 9, it is 0. 0 times 0, that is 0. And how about A2, B2? A2 is 3, 1. It is 3, 1. And B2 is, what is B2? B2 is 1, 4. It is 1, 4, which is equal to 3 times 1, 3, 3 times 4, 12, 1 times 1, it is 1, 1 times 4, it is 4. And the last one, here we have A3, B3, that is 1, 7 times B3, it is 2, 3, which is equal to 1 times 2, it is 2, 1 times 3, it is 3, 7 times 2, 14, 7 times 3, it is 21. Now to get the answer here, let's just write here that AB then equals, we should just add the first components, 18 plus 3 plus 2. That's equal to 23. Because so this product is just equal to the sum of these matrices, right? So 0 plus 12 plus 3, that is 15. And here we have 0 plus 1 plus 14, that's equal to 15. And 0 plus 4 plus 21, that's equal to 0 plus 4. 4 plus 21, that is 25. Right? If you check here, 2 times 9, 18 plus 3 times 1, 3 is 21 plus 2, that is 23. And to get this one, I should multiply the first row by the second column. 2 times 0, 0, 3 times 4, 12, 1 times 3, it is 3, that's equal to 15. All right. Consider the matrices A and B given below. Okay. So here also actually another example for partitioning a matrix. And here, as see here, we can just partition A in this way because at the top here, as you see, we have identity matrix, and here we have 0 matrix, and here we have kind of any non-special matrix. We have matrix. So actually, I can just partition this in this way. So here we have matrix A, matrix B, and matrix C, D. And how about this one? And the second one, also we can just do this in this way because here we have zeros, right? And here we have any kind of matrix. Here we have identity matrix, and we have some kind of matrix here, 1, 1, 0, 3, 2. No, these are not spatial matrices. So if we just write this one as these 4 matrices, A1, 1, A1, 2, the second one, and third one, A2, 1, actually is equal to 0, A2, 2, it is this matrix. How about this B? We can just write this one as B11, B12, B13. And here we have B21, B22, B23, right? We have just partitions these matrices. And now inside we have block matrices here. Okay. So now, actually here we just say that A and B are said to be partitioned conformably for block multiplication. Why? Because here now I can just multiply A by B as if we are just multiplying 2 matrices. Now imagine that here, not matrix, we have just entries here. As see here, all these dimensions actually they are conformable, or it is defined, okay? So here we say that A and B are said to be partitioned conformably for block multiplication, and we can just multiply these 2 matrices in this way. You will see that we will save a lot of time by actually using this method. Guys, now I'm going to stop here. Maybe I will finish this video a bit later and share with you, okay? Now I'm going to talk about your quiz. As I told you, I'm going to send your the quizzes to your email addresses now. You can just download this and do the questions, okay? After that, guys, if you have access to writing on the screen, like if you have like iPad or something and pencil, and opening the file by using Microsoft Edge, you can do on the screen and save it, send it to me. But when you are sending, don't forget to rename the file. Put your name, okay, linear algebra, like M241. I have already sent it in the message. Then send it to me. Now it is 11 o'clock. Let's say sending and takes is about 5 minutes. Okay, you have to send your solutions before 12:30. Okay? If you have any questions, you can just write it to me through using your to our Telegram group. Okay, I will try to answer the questions. Everything is clear. You have to just solve nicely, and when you are scanning, scan in the right order. Okay, like the first question and the second question and third question and fourth question, scan like this. Okay, bye bye.